All right, so it looks like there's a couple of questions that seem like they're kind of not necessarily redundant, but they're kind of asking similar things. So I'm going to do question number 12, and that's going to be the last one for chapter number 4. What that question reads is, what is the molarity of a solution of nitric acid, HNO3, if 2.73, or sorry, 0.273 grams, oop, there we go, grams of Ba, barium hydroxide, OH2, which I'm like 99% barium. Yep, barium's plus 2 ions, so BaOH2. It's required to neutralize 20 milliliters of HNO3. So the question is, how many moles per liter of this HNO3 if 0.273 grams of BaOH2 neutralized, well, 20 milliliters of it. So to do this sort of question, what you need to do is have your balanced chemical reaction. HNO3 plus BaOH2. So this is a strong acid versus a strong base. That strong acid and strong base, they're going to produce H2O and barium nitrate, considering that it makes a neutral compound with a hydrogen ion or a +1, that means that nitrate has a -1 charge. So BaNO3 subscript 2. So that part is balanced. Now what we need to do is we need to come up with the coefficients to make this thing balanced. So we've got a total of 3 hydrogens on the left-hand side. We've got 2 nitrogens on the right-hand side. We got 1 barium. What I'm going to do is I'm going to throw a 2 in front of HNO3. And then let's see where I go. Okay, so this gives me 2 nitrogens. It gives me 6 oxygens, then 7, 8 oxygens. So I got 8 oxygens over here. This gives me 6 oxygens. And now let's throw a 2 in front of here. That gives me 8 oxygens. Where are my hydrogens? I got 2 H's here and then 2 H's here. So that's a grand total of 4. So I got 4 hydrogens here. So just to recount, what I did was I said that I needed 2 moles of HNO3 to react with 1 mole of BaOH2. Now, one way that you could look at this is whenever we have a strong acid and a strong base, say what we care about is this and this. How many of this do you have? We've got 2. So how many of this do we need? We need 2. Okay, so that's your kind of driving force there. At any rate, this is what we got. We got 2 moles of HNO3, or 2 moles of HNO3 will react with 1 mole of BaOH2 to produce 1 mole of BaNO3 and 2 moles of H2O. Now, what we have is we have 0.273 grams of BaOH2. Now, our molar mass for barium hydroxide. Well, barium is 137.33 grams. Oxygen, and we've got 2 of them, is 16 each, so that's 32. And hydrogen, 2 hydrogens, that's 2. So we're talking about 169.33, 171.33 grams of BaOH2 is 1 mole of BaOH2. Okay, so now what we need to do is we need to figure out the number of moles of HNO3. And we have the moles of BaOH2. We've got our balanced chemical reaction. 1 mole BaOH2 will react with 2 moles of HNO3. So we're done because we are looking for moles of HNO3. 0.273 times 2 equals 0.546 divided by 171.33, and I get Sorry. 3.18 times 10 to the negative third moles of HNO3, which is the same as 0.00318 moles. I'm going to take that 0.00318 and I'm going to divide it by my volume. My volume of HNO3 is 20 milliliters. So this would be 0.02 liters. That would mean that I have a solution with a concentration of 0.156 or 159 molar HNO3. That is the concentration of my solution. We had a mass that was reacted with a volume. We had to figure out the number of moles of that substance and then divide it by the volume that we were provided with. Okay, well, that does it for chapter 4. I hope this is helpful and I hope you have a good one.